This is a video from section 1.6 in a linear algebra class. The directions say to find the conditions that B's must satisfy for the system to be consistent. For a system to be consistent, it must have either one solution or infinitely many solutions. Let's take a look at the following example. x1 minus 2x2 plus 5x3 equals b1. 4x1 minus 5x2 plus 8x3 equals b2. Negative 3x1 plus 3x2 minus 3x3 equals b3. And so what we want to do first is we want to set up this augmented matrix. And so I'm going to put a bracket here, right? And in the first equation, notice that the coefficient of x1 is 1, right? So in the first row, I'm going to have 1, negative 2, 5, and then the constant b1, right? So notice that the coefficient of x2 is negative 2, the coefficient of x3 is 5, and then b1 is the constant on the other side of the equation. In the second row, we have 4, negative 5, 8, b2. In the third row, we have negative 3, 3, negative 3, b3. And so I'm just going to draw a dotted line here. It separates out the constants from the coefficients of the variables. And so I reiterate this on this page, right? So here's our augmented matrix. Notice the entry in the first row is a 1. That's good. And so we want to perform a series of elementary row operations using row 1 to turn this 4 into a 0 and to turn this negative 3 into a 0. How do I do that? So I'm going to take negative 4 row 1, add it to row 2, put the result back into row 2. And if we don't mind, at the same time, I'm going to take 3 row 1, add it to row 3, put the result back into row 3. Now, row 1 doesn't change at all, okay? So my matrix, my new matrix will become 1, negative 2, 5b1, 0, that's good, 3, negative 12, b2 minus 4b1. And then the third row is 0, negative 3, 12, and then it's b3 plus 3b1. Now, let's make sure we know how these entries are coming about. For example, how did I get 3? Well, I come over here, I'm going to take negative 4 times negative 2, that's positive 8, and then I subtract 5, and that's what produced 3. To get negative 12, this entry over here, I took negative 4 times 5, and then I added 8, and then I got negative 12. And then you might ask, how did I get negative 3? Right here. Well, I take 3 times negative 2, and then I added 3, right? 3 times negative 2 is negative 6. Negative 6 plus 3 is negative 3. And then I took 3 times 5 to get 15. 15 minus 3 ends up being 12. Okay, now from here, I'm going to take 1/3 row 2 and put the result back into row 2. And that's going to make basically it's going to turn that 3 into a 1. And remember, that's called the leading 1. So when I do that, I get the matrix 1, negative 2, 5b1, 0, 1, negative 4, and then it's 1/3 of b2 minus 4b1. And then in the last row, we get 0, negative 3, 12, and then b3 plus 3b1. Now, from here, I'm going to use row 2 to turn that negative 3 into a 0. Okay, so notice I'm working in sort of like a triangle. How do I do that? So I take 3 row 2, and I'm going to add row 3 and put the result back into row 3. So when I do that, I get 1, negative 2, 5b1, 0, 1, negative 4, and then it's 1/3 of b2 minus 4b1. And then the last row is 0, 0, 0, b2 plus b3 minus b1. So let's write down what we have. From here, we can say x1 minus 2x2 plus 5x3 equals b1. x2 minus 4x3 equals 1/3 of b2 minus 4b1. Okay? And then 0x1 plus 0x2 plus 0x3 equals b2 plus b3 minus b1. Now, here's the deal. If b2 plus b3 minus b1 is not 0, this system is inconsistent. Okay? Because if you pick a number like 9, right? 9 is not 0. Can 0 equal 9? And the answer should be absolutely not, right? So it's an inconsistent system if b2 plus b3 minus b1 is not 0. If b2 plus b3 minus b1 is 0, this system is consistent. And so solving for b1, we get b1 is equal to b2 plus b3. So that's how the b's are related to each other. And that'll conclude this video. Okay, thank you.